Good evening or good afternoon, good morning. It depends on wherever you are. In this video, I will talk about how to construct truth tables. So let's start with the basics. So let's assume we have one variable. So one variable, and we can call it X. So in computer engineering, so this X can have logic 0 or logic 1. So computers either, you have two states, either 0 or 1. So 0, for instance, power is off. 1 is power is on. So the way you create a table, so this is just one variable. So X can have either 0 or 1. So you have two combinations. Then you can create the complement of X. So X on top of it, a bar, is called complement. That means the inverse. So 0, you invert it, is just 1. Then you invert 1, which is just 0. So we have we have two states. So you can have either 0 or 1. So the number of combinations equal to 2 to the power of n, where n is the number of variables. So in this case, I only have one variable. That means the number of variables is equal to 1. So 2 to the power of 1 is 2. So that's why so this is the number of combinations. So the number of combinations, so I'll just write combo, is equal to 2 to the power of n. 2, because we have two states. Either it will be 0 or 1. And n is the number of variables. So now let's take the case where we have two variables. So we have, for instance, x, or we have y, and you can call them. So x can take either 0 or 1, and y can take either 0 or 1. So again, we have two states, so that's 2. And how many variables? So n is equal to the number of variables. So I have x and y, so that's 2. So the number of combinations I would have if I have two variables is 2 to the power of n equal 2, which is 4 combinations. So the way I would create the truth table, so x here and y here. So x can take either 0 or 1. So what we can do, so x and y, they can all be zeros, or x can be 0, y can be 1, x can be 1, and y can be 0, or both would be 1. So I have 1, 2, 3, 4. So those are all the possible combinations if you would have if you have two variables. That's 4. So that's how I calculated 4. Now, what if we have 3 variables? So we have 3 variables. So we can call them x, y, z. So obviously x can take value 0 or 1, the same thing with y, and the same thing with z. So n, the number of variables, is 3. So the number of combinations I would have is 2 to the power of n, which is to the power of 3, which is 8. So if I come here and do x, y, and z, so all of them can be zeros. So that's one combination. X, y is 0 and z is 1. So this is another combination. Another combination. So then you can have, here's another combination. Here's another combination. So if we count them, I have 1, 2, 3, 4, 5, 6, 7, 8. So that's how you come up with 8. So to sum up, so recap, if n is the number of variables, and these variables can be inputs, as we will see later, can be inputs to logic gates. So the number of combinations is 2 to the power of n. 2 because you can, each input or variable can be either 0 or 1. So 1, 2, that's why we have to n. So if you only have one variable, you have two conditions, either 0 or 1, that's 2. So that's kind of in summary how you calculate the number of combinations. So that's it. Thank you and have a great day or evening or night.